Hi everyone. In this lecture we are going to see testing of hypothesis for small samples, namely t-test, f-test and the chi-square test. First we see the basic definitions. A population in statistics means a set of objects. The population is finite or infinite according to the number of elements of the set is finite or infinite. Next we see sampling. A sample is a finite subset of the population. The number of elements in the sample is called the size of the sample. In that we have two things. One is a large and small sample. The number of elements in the sample is greater than or equal to 30, then the sample is called a large sample. And if it is less than 30, then the sample is called small sample. Parameters. The statistical constants like mean, mu, variance, sigma square, etc. computed from a population are called the parameters of the population. Statistics. Statistical constants like mean, x bar, variance, x square, etc. are computed from a sample are called sample statistics or simply statistic. So here we are going to use the notations. Population, nothing but the population parameters, and the sample parameters, namely statistic. So population size, the size of the population is denoted by capital N. Similarly, the sample size is denoted by small n. Population mean denoted by mu. Sample mean denoted by x bar. Population standard deviation is denoted by sigma. Sample standard deviation is nothing but small s. Population proportion is denoted by capital P. Sample proportion is denoted by small p. Test of significance are namely hypothesis testing. So statistical hypothesis. In making statistical decision, we make some assumptions which may be true or false or called statistical hypothesis. So in that we have null hypothesis. It is denoted by H0. For applying the test of significance, we first set up a hypothesis which is a statement about the population parameter. The statement is usually a hypothesis of no true difference between sample statistics and the population parameter under consideration what we have, and so it is called null hypothesis and is denoted by H0. It is denoted by H0. This one. Alternate hypothesis. So H1 this is nothing but H1. Suppose the null hypothesis is false, then something must be true. So this is called alternative hypothesis and is denoted by H1. The notation we use H1. For example, if you consider if H0 is a population mean, mu is equal to 300, then H1 is mu is not is equal to 300. That is, if mu is equal to 300, we use H0, then H1 is nothing but mu naught is equal to 300. In particular, it may be mu is less than 300 or mu is greater than 300. Or simply you can fix strictly mu is less than 300 and H1 may be mu strictly greater than 300. So any one of this may be taken as alternate hypothesis. So these are the possibility. We have to choose H1. Error in sampling. After applying a test of significance, a decision is to be taken to accept or reject the null hypothesis H0. So in this we have two type of errors, namely type 1 error. The rejection of the null hypothesis H0 when it is true is called type 1 error. Second one is type 2 error. The acceptance of the null hypothesis H0 when it is false is called type 2 error. Next one is level of significance. The probability of type 1 error is called the level of significance of the test and is denoted by alpha. So we can take either 5% or 1%, that is 95% or 99%. Next definition is one-tailed and two-tailed test. One-tailed and two-tailed test. So if theta naught is the corresponding sample statistics, and if we set up the null hypothesis H naught is nothing but theta is equal to theta naught, then the alternative hypothesis H1, which may be complementary to the H naught, can be any one of the following. Already we had seen. So all the possibilities, H1 is nothing but theta is equal to theta naught. It may be less than theta naught or greater than theta naught. So giving us to a two-tailed test, that is we have two possibility, strictly less than or strictly greater than. H1 theta is strictly less than theta naught, H1 theta is greater than theta naught, thus giving us one-tailed test. So first one is nothing but two-tailed test. Second and third, strictly less than or strictly greater than, that is we have only one possibility. This is nothing but one-tailed test. So now we are going to see test of significance of small sample. When the size of the sample n is less than 30, so sample size should be less than 30, then the sample is called a small sample. So we have some standard test, namely student t-test, f-test and chi-square test. So first we see student t-test. So in this, the first one is test of significance of the difference between sample mean and the population mean. Second one, test of significance of the difference between means of two small samples. So first we see the test of significance of the difference between sample mean and the population mean. So we use this formula. So the student's t-test is defined by the statistic t is equivalent to x bar minus mu divided by s by root of n minus 1. So with the degrees of freedom, mu is equal to n minus 1, where n is sample size, x bar sample mean, mu population mean, and small s standard deviation of the sample. So now we see the working procedure for applying this test. So first we choose H naught, mu is equivalent to x bar, that is there is no significant difference between sample mean and population mean. H1 may be any one of the alternative hypotheses, namely mu is not is equivalent to x bar. So we use it as the two-tailed test, or H1 may be mu is strictly greater than x bar or mu is strictly less than x bar. So one-tailed test. Then using the formula t is equivalent to x bar minus mu divided by s by root of n minus 1 with the degrees of freedom mu is equal to n minus 1, and choose the level of significance. It may be 5% or 1%. Then get the conclusion if our calculated value and take the absolute one. So if modulus of t is less than the table value t of it may be 1% or 5%, it depends upon the problem. So then H naught is accepted at 5% level of significance. In case if modulus of t is greater than t of 0.01, that is our calculated value is greater than table value, then H naught is rejected at 5% level of significance. First problem we are going to see. A machinist is making engine parts with axle diameter of 0.7 inch. A random sample of 10 parts shows a mean diameter of 0.742 inch with the standard deviation of 0.04 inch. Compute the statistic you would use to test whether the work is meeting the specification. So first we have to analyze this problem. So here what are the sample size? So sample size is 10, so which is less than 30, therefore the sample is nothing but small sample. And here sample mean is given, x bar is nothing but 0.742, that is a sample mean is given here. So sample mean is given 0.742 with the standard deviation is nothing but a 0.04. So standard deviation is given, and the population mean is also given, so it is nothing but 0.7. And now we have to fix the null hypothesis. So null hypothesis, we take mu is equal to 0.7, that is the work meet the specification we have to choose. Alternatively, we can choose mu not is equivalent to 0, but that is the work does not meet the specification. So that is, again I repeat, null hypothesis is nothing but h naught, that is mu population parameters we are going to take, mu is equivalent to 0.7. Alternative hypothesis, h1 mu not is equivalent to 0.7. And here the level of significance is not mentioned in the problem, therefore we can choose the level of significance should be 5%, that is alpha is equal to 0.05. With the degrees of freedom n minus 1, that is 10 minus 1, it's nothing but 9. Now we apply the formula, t is equivalent to x bar minus mu divided by s by root of n minus 1. We use this formula, and x bar is 0.742, minus mu is 0.7, s is 0.04, and divided by root of n minus 1, nothing but 10 minus 1. So after simplifying this, you may get 3.15, and here it is the positive value, and modulus of t, that is take the absolute value. In case if you have negative value, we can take it as positive, so absolute value of t is nothing but 3.15. And now from the table we can get table value with the degrees of freedom n minus 1. N minus 1 is nothing but 9, and the level of significance is nothing but 5%. So now we see the table. So here we are going to see this one 0.025. This is nothing but in two-tailed test. This is two-tailed test, right? So here you are going to see, so 0.025. The level of degrees of freedom is 9, so the value is 2.262. So this is the table value. Now our calculated value is 3.15, which is greater than the table value 2.262. So now we can get the conclusion. So the t calculated value is greater than t table value, so we reject the null hypothesis h naught. That is, the product does not meet the specification. So now we see the second problem. The mean lifetime. The mean lifetime of a sample of 25 light bulbs produced by a company is computed to be 1570 hours with a standard deviation of 120 hours. The company claims that the average life of the bulbs produced by that company is 1600 hours. Using the level of significance of 0.05, is the claim acceptable? So we need to analyze this problem first. So here what is n? The size of the sample is nothing but 25, so which is less than 30. So the sample, we consider it as small sample. And here sample mean is given, so 1570 we denoted by x bar, and population mean mu, the whole company lifetime of the bulb is nothing but 1600, so mu is 1600. Standard deviation of the sample is given, which is nothing but 120 hours, so s is 120. So we need to analyze based on this the claim is acceptable or not. So first we have to fix the null hypothesis h naught mu is equal to 1600. So the claim is acceptable, and alternative hypothesis is nothing but h1 mu does not uh, equal to 1600, that is mu not is equal to 1600, and level of significance given in the problem, so we have to choose the same. So alpha is nothing but 0.05 with the degrees of freedom n minus 1. So size of the sample is nothing but 25, so 25 minus 1 is 24. Now we use the formula, same formula, t is equivalent to x bar minus mu divided by s by root of n minus 1. So x bar 1570 minus 1600 divided by 120 divided by root of n is 25, so 25 minus 1. After simplifying this we can get a minus 1.22. So t, take the absolute value, is nothing but plus 1.22. Table value, so we can see from the table, we can get the value from the table. So with the degrees of freedom 24 with 5%, so two-tailed test, we are going to see the third column value. So here I highlighted. So for 24 the value is nothing but 2.064, so 2.06. so the calculated value is nothing but 1.22 and the table value is 2.06. so we can get the conclusion our calculated value is less than the table value, therefore h naught accepted, that is the null hypothesis should be accepted. That is the average life of the bulb produced by the company is acceptable. Now we are going to see one more problem. The mean weekly sales of soap bar in a departmental store was 146.3 bars per store. After an advertising campaign, the mean weekly sales is 22 stores for a typical week increased to 153.7 and showed a standard deviation of 17.2. Was the advertising campaign successful? So now we can analyze this problem. So here the size of the sample is nothing but 22, which is less than 30, therefore the sample comes under small, and sample mean x bar is 153.7, so here this is given, and the population mean is given, the whole 146.3, and standard deviation is given 17.2. So now we can apply the same test. First we have to fix the null hypothesis h naught. So mu is equivalent to 146.3. So alternate hypothesis. So now we look at the problem. Based on that only we can choose the alternate hypothesis. So after advertising, okay, that is advertising campaign successful or not. So successful is nothing but the average should be increased. Therefore we can take the alternative hypothesis should be mu is greater than 146.3. The level of significance we choose 5%. The degrees of freedom n minus 1, nothing but 22 minus 1, 21. Now we apply the same formula. T is equivalent to x bar minus mu divided by s by root of n minus 1. So 153.7 minus 146.3 divided by 17.2 divided by root of 22 minus 1. So using a calculator we can simplify, we can get 1.97, and absolute value is nothing but the same, 1.97. Now we can see from the table, so T alpha n minus 1, that is 5% with the degrees of freedom 21. Here we are using a one-tailed test. So one-tailed 5% is nothing but in the fourth column we are going to see. So 21 With the degrees of freedom 21, the value is 1.721. So 1.72. Now we look at the observation. Our calculated value is 1.97. Table value is 1.72. Therefore, calculated value is greater than the table value. So now we reject the null hypothesis H0. Therefore, we accept the alternative hypothesis H1, that is mu is greater than 146.3, which means the advertising comparison was successful. One more problem we are going to see. A random sample of 10 boys has the following IQs: 70, 120, 110, 101, 88, 83, 95, 98, 107 and 100. So do this data support the assumption of the population mean IQ of 100 at 5% level of significance? So now we can analyze the problem. So here sample size is given 10, which is less than 30. Therefore, we take it as small sample. And here the observation values are given. And the population mean is given, mu is equal to 100. So alternative hypothesis we may choose H1, mu is not is equivalent to 100. And level of significance is given 5%. So we use alpha is equal to 0.05 with the degrees of freedom n minus 1. So n is 10. So 10 minus 1 is equivalent to 9. So the same formula we are going to use. T is equal to x bar minus mu divided by s by root of n minus 1. So here x bar and s value is not given directly. So first we have to compute that one. After that we have to apply in the formula. So x values are given: 70, 120, 110, 101, 88, 83, 95, 98, 107, 100. So for these values we have to take the square. So x square value is given here, and we can calculate summation x. Summation x is nothing but 972, and the summation x square is nothing but 96312. So we can calculate first the variance of the sample is nothing but s square by using the formula summation x square by n minus summation x by n whole square. So 96312 divided by 10. So n is nothing but 10 minus summation x is nothing but 972. So divided by 10 whole square. So the first simplification is nothing but 9631.2. The second one 9447.8. So after simplifying this, we can get s square is equal to 183.4. Therefore s is equal to, take the square root, nothing but 13.543. So now we got small s, standard deviation of the sample, and the x bar also we got. So x bar is nothing but 972 divided by 10, so 97.2. So once we get all the values, we apply the formula T is equivalent to x bar minus mu divided by s by root of n minus 1. So x bar is 97.2 and mu is 100. So s value is 13.543 root of n minus 1. So 10 minus 1 is nothing but 9. So after simplifying this, we can get minus 0.62. So which is negative. So take the absolute value is nothing but 0.62, that is positive. And from the table we can see 5% the degrees of freedom is 9. So we can see here degrees of freedom 9, the table value is 2.262. So observation is our calculated value is 0.62, but table value is 2.262. Therefore we can accept the null hypothesis. Calculated value is less than the table value, so we accept the null hypothesis, and we can get the conclusion that the data are consistent with the assumption of mean IQ of 100 in the population. So the general idea is, first you have to analyze the problem, what are the things are given, which formula we are going to apply, and then choose the level of significance, and then take all the value from the problem and then apply in the formula, and compare with the table value, and then finally get the conclusion, that is we are accept or reject. In the next class, in the next lecture, we are going to see testing of significance of the difference between means of two small samples. So we had seen the first one. We have a population, and we have a sample for this mu and for this x bar. So we had seen, is there any significant difference between population mean mu and the sample mean x bar? So we can analyze this too. So now in the next class we will see the test of significance of difference between means of two small samples. That is, we have a population is given, and we consider two small samples. So we can use first one x1 bar sample mean, second one we can choose x2 bar. So this is nothing but mu we can use, and here the size of the sample should be n1 in the first sample, and here we can take size of the sample should be n2, and the mean we can take it as x1 bar, second one is nothing but x2 bar, and here sample standard deviation small s1, and here we can take small s2. Sample standard deviation of the first one is nothing but s1, and here we can take it as s2. So based on this we can use, so to test the significance of the difference between two means x1 bar and x2 bar of sample size n1 and n2 respectively, we use the formula T is equivalent to x1 bar minus x2 bar divided by capital S into square root of 1 by n1 plus 1 by n2, where capital S is equivalent to, we can calculate by using this formula, again square root of n1 s1 square plus n2 s2 square divided by n1 plus n2 minus 2. With the degrees of freedom, mu is equivalent to n1 plus n2 minus 2. So first we have to calculate capital S. Once if we get capital S, we can apply here. To simplify this, we can get T. So based on this, we can calculate and choose the level of significance, and see in the table value. So the same conclusion we are going to use. If calculated value is less than the table value, then we can accept the null hypothesis. Otherwise we can reject the null hypothesis. So if in the given problem we need to analyze the means, we can use t-test. So the idea is, first we have to choose or check the sample should be small sample or large sample. First one we have to analyze. So small or large sample. So once if it is small sample, then the problem may be discussed with means or variance. So first we have to choose or identify which one is correct one. Means or variance we need to analyze. If means come, we go for the student t-test. So in that we have to analyze, we need to analyze population mean and sample mean or difference between two sample mean. So first we have to analyze step by step, then choose the suitable test, and then we can apply and get the conclusion. So these are the basic things. Thank you.